This question is from GATE 2011 Mechanical Engineering paper, question number 47. A cubic casting of 50 mm side undergoes volumetric solidification shrinkage and volumetric solid contraction of 4% and 6% respectively. No riser is used. Assume uniform cooling in all directions. The side of the cube after solidification and contraction is dash. So it's given that volumetric solid contraction is 6% while volumetric shrinkage is 4%. Now volumetric solid contraction refers to the decrease in volume that occurs when the metal cools down but when it is still in the liquid state. So we can write contraction happens in liquid to liquid state itself. There is cooling, so the contraction happens but the final metal is still in liquid state. While shrinkage happens when this liquid or the molten metal is cooled down to solid state. So shrinkage is from liquid to solid state. So when we consider the decrease in volume, we will have to consider it in two stages. First stage being the decrease in volume due to solid contraction. Let the initial volume be Vi. So final volume after contraction will be VFC. And in the second stage, after volumetric shrinkage happens, let the final volume be VFS. So the final volume that we are looking for is the absolute final, that is after the shrinkage that happens. So when we apply the decrease in two stages, we will get VFC, that is after contraction, will be equal to 100 minus 6% into Vi, which is nothing but 94 by 100, that is 0.94 times Vi. Now the absolute final volume Vf is nothing but Vfs after volumetric shrinkage, which will be equal to 100 minus 4%, the amount of shrinkage, but this decrease is happening on this volume. So we'll have to multiply this with 0.94 Vi. So final volume will be 100 minus 4, 96 by 100, which is 0.96 into 0.94 into the initial volume Vi. Now we need to find the change in side, that is we need to find the new side of the cube. To find out the new side, it's a cubical geometry, so we can do new side, let that be A dash be equal to cube root of Vf. That's what will give us the new side. Let the initial side be small a, which will be cube root of Vi, the initial volume. Now A is given to us, side of the cube, as 50 millimeters. So we can write Vi is 50 cube. Let's substitute the value to find out Vf. Vf is equal to 0.96 into 0.94 into 50 cube. This comes out to be 1,12,800. The side is in millimeters, so we have millimeters cube is the unit of volume. This is the final volume. The final side will be cube root of this value. So we have cube root of 112800. This comes out to be 48.32 and the unit will be millimeters because it is the new side. Let's go back and mark the correct option. We have answer is option A. 48.32 millimeters is the side of the cube after solidification and contraction. To learn more about allowances, shrinkage and contraction are the allowances given while designing the casting and the riser. So to learn more about allowances, you can refer to the NPTEL video Allowances in Pattern Making from the course Principles of Casting Technology. This course is by Dr. Pradeep Jha. He is from Department of Mechanical and Industrial Engineering, IIT Roorkee. I hope the solution will help you clear it out. Thank you.